for Space Environmentalism. Dr. Jha, the floor is yours.
Thank you very much. Hopefully everybody can hear me. And one of the things that I wanted to say before I even start is I also want to give a land acknowledgement. I am presently here in Washington, D.C., and I'd like to open up by acknowledging that I'm here speaking to you on the lands of the Nacotchtank and Piscataway people, amongst others. And I also ask permissions to be able to speak to you today in ceremony from the north, the west, the south, the east, above Father Sky, below Mother Earth, and the formidable mycelial network, and within. So thank you very much, and let us begin. So as everybody knows, technology always works. So I'm going to share my screen, and of course, nothing's going to go wrong. So first and foremost, much like we are whole beings with different systems, we have skeletal system, nervous system, and whatnot. Mother Earth, or Gaia, also has many systems. And these can be comprised of land, air, ocean, but there's also space. One of the things that we've been seeing is that as we explore, as we conduct our lives, we have forgotten the interconnectedness across all these systems. We have forgotten the interconnectedness amongst all things. And we have also abandoned our intergenerational contract of stewardship. And this is the result. We believe ourselves to be independent of each other. What happens in one part of the world doesn't affect the other part and whatnot. And Mother Earth is giving us feedback of the unintended consequences of our actions. These unintended consequences of our decisions are leading to our self-extinction, inarguably so. Our decisions are outpacing Mother Earth's ability to inform us of what it means to have a successful conversation with the environment. But while most people are distracted with what's going on here on the surface of the Earth, the thing that people don't really see is what's going on in space. Much like we have explored to the detriment of land, air, and ocean, we're exploring space to the detriment of that space environment. In 1957, we launched Sputnik, but today we track over 50,000 objects ranging in size from a cell phone to the space station in different orbits. And while this is an exaggerated view, this is exactly where we're heading. Why should we care about these robots in the sky that we call satellites? Well, because our way of life depends on critical infrastructure in space. Imagine losing GPS, a way that governs everything from air traffic to how we get from one point to the other, how we monitor different parts of our economy, things that keep us connected with each other across the globe, how we communicate with each other on a daily basis. We have internet from space now. Financial transactions also go through space-based infrastructure. And nothing is protecting these assets from harm. We know more about planet Earth because of these robots in the sky that we call satellites than by any other means of information. But to make matters worse, much of what we launch in space in low Earth orbit comes back. These are real images, people. These are things the size of buses and cars coming down in places that we can't predict. And this is only going to get worse. Coming to a theater, school, hospital, community near you. The sky is falling, and it's going to fall a whole lot more unless we do something about it. This is what not being honoring interconnectedness means. This is what not being a steward means. we are losing our skies as well. The dark and quiet skies are much less dark and quiet. But I do have some good news. There are pockets of people across this planet who have, for thousands of years, for many millennia, honor and respect and believe in the interconnectedness amongst all things. They also embrace this intergenerational contract of stewardship and accept that they live in an existential crisis, and the only way through it is to have a successful conversation with the environment. And these principles, these tenets, are captured in what's called traditional ecological knowledge, or tech. I call it ancient tech. These are the guardians of our planet. You didn't see them while you were in school, in your classrooms. They don't have PhDs and medical degrees, but they do bring value to stewardship of our planet. And we can embrace this ancient tech and marry it with our high tech and deep tech to really scale the ability to achieve sustainability and environmentalism in ways that will extend the expiration date of humanity. We come from the stars. Our skies are affected. We have lost touch with our sky. Most of us live in places where we have so many city lights, we don't even know what stars look like. And I feel this has really disconnected humanity from our origins. We have to continue exploring space. This blue dot in our solar system, the only home that we know, spaceship Earth, also has an expiration date, because eventually the sun runs out of fuel, and that's it. And if we can't transfer humanity to another solar system, then that's it for us as well. So let's buy ourselves some time and work on that stewardship and embrace the interconnectedness. Now, the other thing that I'm going to show you to put things into context is Wayfinder. This is an application that I developed at the University of Texas at Austin that I was able to transfer into this company, Privateer, that I co-founded last year with Alex Fielding and Steve Wozniak, the co-founder of Apple. You can go to privateer.com and you can see this right now. So this is like live, okay? So you can see all these, every single dot is a human-made object currently orbiting the Earth. The blue dots are things that work. Everything else is garbage. Everything else is garbage. And we have these highways in our skies in orbit that are becoming more and more congested. We are not behaving sustainably in space because we don't even have a global system that helps us coordinate and plan when we launch, how we launch. Basically, it's a first come, first served type thing. Again, it's this belief of independence. It's not honoring and respecting our interconnectedness and recognizing that we need to manage this delicate ecosystem holistically. Now, when we talk about these orbital highways, I can show you this to put things in a more perspective. I'm taking 4,000 of these human-made objects, snapshot in time, and this is just in Euclidean space. This outer ring is called the geosynchronous ring, where it takes about 24 hours for a satellite to go around its orbit once, which is a great place to put things like DirecTV and that sort of thing, so people don't have to repoint their dishes. And then things here are low Earth orbit, closer to the planet. Now, the color coding of the dot represents its orbital inclination with respect to the equator. That means that if it's orbiting around Earth's equatorial belt, then it's going to be a 0-degree inclination orbit. And if it's orbiting right over the poles, it's 90 degrees inclination. Okay, that's what the colors mean. Now, if I take the cross products of the position and velocity vectors of these objects, that gives me a different space called specific orbital angular momentum space, And these are the same 4,000 objects on the right. And you can see these rings, and I haven't done anything magical. All I did was a simple math operation. And you can see these rings, they're structured. It's not random. We don't put things in random places. These rings are the orbital highways that I'm talking about, and they're real, and they're becoming more and more congested. And we don't have a successful way to converse with the environment and manage this to avoid the detriment to the space environment and orbital space. Moreover, if we ask the question, over the next 20 minutes, which pair of objects can we predict will crisscross each other's path? And this is what we get. This is very busy. These are objects that are coming within 10 kilometers of each other, predicted over the next 20 minutes continuously. Green dots are a pair of objects where both are working. Yellow dots, one is working and one is defunct or dead. And red dots are two pieces of junk. And the relative speeds are spiking on this histogram 15 times the speed of a bullet. And the smallest thing that we're tracking is the size of a cell phone. So if a cell phone, many times larger than a bullet, is traveling at 15 times its speed relative to something else, if these things collide, it's cataclysmic. It's a bad day. Now, what's the detriment of all these objects to the skies? Well, for people on the ground, here's an image of what the reflected light off of these objects looks like to an astronomical instrument on the ground. These streaks are light being reflected from these objects towards the camera. Astronomers have to pierce through this clutter every night to try to get science out of it. And oh, by the way, it's not just trying to find gamma ray bursts and that sort of stuff. It's also trying to detect near-Earth asteroids that also could bring an end to spaceship Earth and, life as we know it. We've seen that before. We have evidence in dinosaur bones and that sort of thing. So this is an issue that we need to contend with. We need to do something about. One of the things that we're also researching is how do we better characterize objects in space. What you see here is a CAD model of Topex. It's a dead satellite around 800 kilometer altitude. It's tumbling. But we can't really see the size, shape of these objects because they're either too far or too small. So we don't see all this detail. What we do see are these dots. These dots are reflected light from Topex. They're photons, and we can count photons as a function of time. And so we need to solve this inverse problem of, given the structure and how light is reflected that looks like this bug or Kal-El's spaceship from Superman, what is the object that actually generated it? So that we can try to find a way to create biometric signatures of these objects and even develop the first ever taxonomy or classification scheme for these objects, because we don't have one right now. So what I want to say to everybody, and I know that my time is brief, is we have a problem in the fact that we don't honor this interconnectedness amongst all things. We have a problem in that we are not embracing stewardship as our way of life for spaceship Earth. And we need to honor that, and we need to protect the environment from further detriment. We can do this. We can invoke ancient tech, and we can marry it with Western science to come up with a holistic way to take care of spaceship Earth, not just for us, but the voices of those to come, the voices of those that aren't here yet. That's the ultimate inclusion, is to provide a voice to the ones that are yet to come. And so I leave you with these thoughts, and I'm looking for collaboration. I can't do this by myself. Spaceship Earth is a system of systems, and it hasn't been really explored holistically, looking at all the interdependencies across land, air, and ocean, and space. And so that's what I'm asking for, and that's what I'm invoking from you. Technical problems exist. political problems abound, but the most difficult thing that I've seen that we haven't solved yet is the lack of empathy. And so how do we recruit and attract empathy across humanity to solve these things? And with that, I just want to say thank you very much.
Thank you, Moriba. Thank you very much for this inspiring presentation.
Totally. We might take one question. Yeah.
Yeah, we have time for one question. This is quite amazing how the things are linked, and the analogy between what we did in the oceans and what we are doing in outer space. So we open the floor for questions if you have it. Please.
Take one question. Does anyone want to ask Dr. Jha a question?
This is a unique opportunity, huh? Moriba
Yeah.
is just prepared to answer.
Please.
Is there? Can you have the microphone, please?
Thank you.
Catherine de Freitas from Triazores. I reside in Portugal. Thank you very much for your presentation and bringing this attention that we're also polluting our skies. What are the solutions of cleaning that up? What are the next steps if we want to really work on it and not destroy it? And then how do we take it from there and bring it down? How do we recycle that?
Great. So I love the question. So two things. There's space debris remediation, which is the cleaning part. And there are companies right now that are building technologies coming from the fishing industry, nets, harpoons, these sorts of things. But there are companies that have technologies to remove some of these things. And ClearSpace is going to be launching in 2025 to remove something. There's Astroscale and some others. But it's not yet something that's monetizable. So government needs to basically help by making salvage laws. Like we have salvage laws in the oceans, we need salvage laws in space so that people can actually make money, because at the end of the day, that's what is going to drive people beyond altruism. When it comes to mitigation, which is the prevention of pollution, my proposal is for governments to usher in the development of a circular space economy that incentivizes industry to design satellites and rockets that are not single use, that are recyclable and that are reusable. And we see launch vehicles that are reusable. Elon Musk has demonstrated that, but we don't have reusable and recyclable satellites, and that would be the next step. And for the things that have to be single use, then we should look at what responsible disposal means versus abandonment, which has led to a lot of the pictures that you saw of things falling back to the earth and crashing, next to some actually populated areas.
Thank you, Moriba. And more complex than this, Yvette, is the international cooperation that we need to tackle these problems, and particularly to implement the zero debris policy that we are doing here in Europe. Thank you, Moriba, for your nice presentation. And I think we can move down from space to Earth and to the volcanoes. Thank you, Moriba.
Thank you. Much love and aloha.